Hello. So I'm solving Hurricane by Philip Newman. This is a classic Sudoku. So normal Sudoku rules apply. There are no special variant rules. We just have to fill the digits 1 through 9 into each row, column, and 3 by 3 marked region. Now, the first thing that stood out to me looking at this puzzle is that I have these pairs of digits that match in two boxes that are kind of adjacent to each other, that see nearly the entirety of a third box. So for example, I have this one in row 1, this one in row 2, and also I have only a single gap in box 3 and row 3 where I can place that 1, so that is a hidden 1. And so I'm going to look and see if I have anything analogous to that elsewhere. And I see here at the bottom I have these 7s. 7 in row 7, 7 in row 8, and so I have to place a 7 here because there's nowhere else for it to go in row 9. I see a hidden 4 in box 9 because I have two 4s. Once again, this pattern of having two given digits that see nearly the entirety of a box. That gives me a 4 here. And now that I've placed that 4, I can use that 4 and this 4 and the one that was given in the middle at the beginning to place a 4 in box 6. And I don't think I get another 4 over here just yet, but let's hold that thought. This 2 and this 2 let me place a hidden 2 in this box. And I actually really enjoy puzzles in particular that let me place a lot of hiddens, even though I'm probably not looking at naked digits where there's only one digit that can go in a position. I do find that looking for hidden digits is usually faster when you're speed solving, as long as there are hidden digits to be found, just because you don't have to iterate through every possibility in your head. You just have to look at 1 or 2 or 3 digits that are all the same and then kind of compare those to a position. So what I'm seeing now is that I have these two 9s that see almost all of box 1. And now I have two 9s, and this is kind of echoing this situation with these 4s over here. I have two 9s that see almost all of box 4, so I have to place 9 in box 4 right there. What else do we have? All right, I need to place an 8 in column 2. It can't go at the bottom because of this 8 in the box. It can't go in row 3 because of this 8 here, so I'm going to place it here. And I need to place a 6 in box 7. I see a 6 here and a 6 here, and that clued me into the fact that there's only one place that I can put a 6 in that box, and it is right there. Now we may have to look for some naked digits, which means that we may have to do a little pencil marking. So I'm looking now at what my most restricted rows and columns are, and the thing that's standing out to me now is column 7. So I've got a 1, 2, 3, and 4, and a 6 and 9, which means I still need a 5, 7, and 8. And I definitely have a 5 and 7 down here, so this is going to have to be the 8. I've got a 7 here, which makes this a 5, and I need a 7 up at the top here. Here I have 1, 2, 3, 4, and so I still need a 5, 6, and 8. The 5 at the bottom of column 8 is going to eliminate 5 from those positions and make this a 5, and then this 8 that I placed earlier is going to resolve the 6, 8 pair. Across here, I need a 3, a 4, and a 6, and I have two 4s in 2 of those columns already, so that's going to be my 4, and I'll just leave that as a 3, 6 pair for now. I also need a 7 here, and there's only one position it can go in. And I need a 2 and a 5, and there's a 5 in this column already, so I'm going to place those there. That gives me a row that has 7 digits filled in. Actually, 2 rows that each have 7 digits filled in. This one still needs a 3 and a 6. The 6 will make that a 3. This one still needs a 4 and a 5. The 5 here will make that a 4 and a 5. What else looks restricted? So this column has 7 digits filled in at this point. I still need a 7 and a 9. And there's a 7 already present in row 8, so that's going to make this a 9 and make this a 7. I'm going to need a 1 and 2 to finish this box. And I'm going to need a 6, 8, and a 9 to finish this box. I can make some eliminations, but I can't quite totally resolve those yet. I'm seeing 2 more rows that have kind of become very restricted at this point. So this row, the only missing digits are 1, 2, and 3. But this column already has a 1 and a 3, so that's a 2, that's a 1, and that's a 3. And now I'm down to just 2 remaining digits needed in this column. So I need a 4 and a 5, and they're going to have to go this way around due to the 4 in row 7. Now I need to place a 1 and a 3 here. Don't know which way those go yet. My remaining digits in this row are 1 and 6. The 1 makes this a 6, and I'm going to pop up here real quick and resolve that 3, 6 pencil mark I made a little bit earlier. Here I need a 2, an 8, and a 9. I'll mark those, but I don't see an immediate way to resolve them, so I'm going to come back to them a little later. Now, what do I need in this column? I need a 1, 3, and 8. Again, nothing jumps out at me as immediately resolvable, so we'll just hang on to it for now. Here I need a 1, 2, 3, and 4. This cell can't be a 2 or 4, so it's a 1 or 3. So that gives me a 1, 3 pair, meaning I can immediately eliminate 1 and 3 from these cells. And because there's a 4 in row 5, I can eliminate 4 from that cell and make that a 2. Now what else do I need? In this column, I have to place a 7, 8, and 9, and the 7 can only go in one spot in the column, so it's going to go right there. And that means my remaining 2 digits are 8 or 9, and now if I compare that to row 6, I have an 8, 9 pair. So that's now a 3, 1, and 8, and I can resolve this stuff down here. And my remaining 2 digits after I've placed that 8, 9 pair are going to be 2 and 5. The 5 makes sure that this is going to be a 2. Now the 2 that I've placed is going to resolve this triple at the bottom. Once that's resolved, I can now do the 8, 9 pair and finish box 6. These cells need a 3 and a 6 in that order, and then our last 2 digits to fill in are going to be 1 and 9. And that's how you solve Philip Newman's hurricane.